All right, for this next example, go ahead and read through it. And we've already solved several that are like this, but I'd like to take you a little bit further with these. So, what I'd like you to do right now is pause the video and work this problem using the same methods that I taught you before. And then once you've got the answers, come back and then I'm going to show you another way to arrive at those answers. So, go ahead and pause. All right, you should have gotten, for the ground speed, approximately 417.245 miles per hour. And for the course, you should have gotten 210.253 degrees. All right, so now we're going to do this in a different way. So another method. Now, when I first introduced you to these problems, I told you that the ground speed is equal to the airspeed plus the wind speed vectors. Now, if we keep that in mind, then we can use component forms of these vectors in order to do what we need to do here. So for my ground speed there, I'm going to rewrite my airspeed and my wind speed in component form. Now with these, I'm just going to go ahead and use the angles as clockwise rotation from north. So for my airspeed, that would be magnitude 425 cosine of 212 degrees. And then 425 sine of 212 degrees. That's my airspeed vector. So now for wind speed, it says the wind is blowing from the west at 15 miles per hour. So since my rotation was clockwise from north, if the wind is blowing from the west, that means it's blowing toward the east. So that would mean the angle for that one would be 90 degrees. And the magnitude is 15. So what I'm adding to this one would be 15 cosine 90 degrees, and then 15 sine 90 degrees. Okay, so when I add those together, I would get the component form of the ground speed vector. And I would be doing that, of course, using a calculator. And I just put in the horizontal component of the first vector plus the horizontal component of the second vector. And when I did that, I got negative 360.42, and then there was a 0 for the third decimal place. And for the y component, I'm putting in the y component of the airspeed plus the y component of the wind speed, and that gave me negative 210.216. Okay, so now this gives me a component vector for my ground speed. So if I wanted to find out what the ground speed is, I would just need the magnitude of that vector, which now that I've got the horizontal and the vertical components of it, that's easy to find. I can just use Pythagorean theorem. So I would take the square root of negative 360.42 squared plus negative 210.216 squared. And of course, when I do this in my calculator, I would be doing the inside part first and then taking the square root of the result. And I should arrive at 417.245 miles per hour. Alrighty, which is what we got for the ground speed when we did this geometrically, like we had learned before using law of cosines. Now, in order to find the course, I'm going to draw a little bit a picture here, and I'm going to try to not make this confusing. This has a tendency to be a little bit confusing. I'm going to draw in a coordinate plane. And then I'm going to draw this vector, this component vector here. And I'm just going to keep it as our uh, usual direction there, just so that we can just find an angle in standard position, like we did before. We'll take this back and relate it to our geometric um, representation in a few minutes. But if my ground speed vector is negative 360.42, negative 210.216, then when I draw it, the tail of it would be at the origin, and for the head, I'd have to go 360 point something to the left, and then 210 down. So about like this. The magnitude of that would be 417, but that doesn't really matter too terribly much right now. Okay, the angle that I'm looking for now would be this angle right here in standard position. I'm going to call it theta. And the way I'm going to go about finding that is I'm going to draw in a right triangle here. It kind of fell off my grid. Oops. Okay. But anyhow, so this side of my right triangle is 360.42. And this side of it over here is 210.216. And I could use right triangle trigonometry to find this. Since I know those two sides of the triangle, this would be a tangent problem. So I could say, well, tangent of that little angle in there, we'll call it alpha. Tangent of alpha is equal to the opposite side over the adjacent side. Now those were both negative, of course, when I first wrote them, but negative divided by negative is positive, so I just left the negatives off. Now to solve for alpha, I would take the inverse tangent of that quotient. My 4 keeps coming out looking like a 9. That's dangerous. All right, so I would put that in my calculator, and that gives me approximately 30.253 degrees. Now that's just that angle alpha. That's the one that's inside the triangle there. I need theta, which is from the positive x-axis all the way over there. So that would be alpha plus 180 degrees. So my theta, my course, would be 180 degrees plus that alpha that we just found. So when I do that, I would get 210.253 degrees, just like we did when we did it geometrically and using the law of cosines. Okay, so now you try the next example on the form there. You have two different methods to try there. It's a good idea to put them together and make sure that you're getting them right, so that way you can figure out if something's wrong. And of course, if you have questions, come and see me in Zoom and I will help you out.